Hi, good morning, everyone. Let us give maybe 1 more minute for everyone to come in. Yeah, so everyone who is here, good morning, ladies and gentlemen. We will be starting our SCPTER Spotlight session shortly. Just a few more seconds as we wait for more people to stream in. Okay, good morning, ladies and gentlemen. Welcome to our SCPTER Spotlight session by the EU Business Avenues Program in Southeast Asia, focusing on environment and water technologies, where we have a series of presentation sessions highlighting of some of our latest innovations showcased by our EU companies exhibiting at the EU Pavilion. My name is Amanda, and I am your MC for this morning. First, we'll have Daliang from Laser Diagnostics Instruments to share his presentation. Daliang, please.
Yes, hello, good afternoon, ladies and gentlemen. I'm just waiting for the slide to appear. Yes, perfect. So my name is Liang from Laser Diagnostic Instruments. We are a small little company, and if you could go to the next slide. So we've been around for almost 30 years. We specialize in remote sensing technology. We are located in a small Baltic country in Estonia, just south of Finland, part of the European Union. And our specialty is in research and development and as a manufacturer. Next slide. So our main product, and the main product that we want to showcase, is called the Remote Optical Watcher, or RO. And it's a non-contact oil spill alert sensor, or oil on water detection system. Basically, it's a sensor that looks like a flashlight or a camera. It looks at the surface of the water and monitors it in real time for oil spills. And it uses fluorescence UV technology. When an oil spill occurs, it alerts the user to the occurrence in real time. Next slide. So why would you want to use our instruments? Well, the main purpose of early detection, early warning, is that you could reduce damage, you could reduce costs, you could reduce loss, and you could reduce downtime. And this works across different applications, especially in environmental and industrial monitoring. Next slide. So traditionally, when we first developed this instrument, our idea was that we would market towards ports, shipping ports, where the ships would come in for to offload cargo. Maybe they would illegally discharge birch water, or there would be illegal dumping or oil spills in the ports. And that was quite successful. We developed a good market for that. Here we have an application in Poland, which is monitoring the anchorage point or the shipping points for the ports. Next slide. But over the years, especially in the last 4 to 5 years, our applications have evolved. We've changed completely who we target our instrument, and now we target mostly the water sector. And one of these applications would be the municipal water sector. So we have an application in the Dubai International Airport detecting fuel runoff from cars and diesels and motors. We have another installation in Thailand, which is an automobile manufacturer. So we detect the runoff from their manufacturing plants for the water, wastewater, processed water that goes directly into the sewer and into the local water waste treatment plants. And it's specifically looking for oil on water, for oil pollution. Next slide. And in terms of applications, we have some very unique ones. This is in Spain. This is a Coca-Cola beverage bottling plant. If you could imagine the size of a plant, it's quite large, and they use a lot of water. and they also collect a lot of rainwater for that purpose. And all the rainwater is then discharged into the local environment. In this particular application in Coca-Cola is basically monitoring at the outer skirts of the plants, and that's why you have the solar panel and telemetry to be able to supply power to that. Next slide. We do have some installations in Malaysia. So one of the unique applications that we have developed or that we have found is that power plants would use our instruments. So either a power plant in Malaysia uses our instrument for intake water because they take water from the sea to desalinate in order to use the water for cooling, or conversely, you can monitor the water that is discharged from the power plant that is used for churning the turbines. So both applications will work, intake and outtake for power plants. Next slide. In terms of water treatment in the water sector, we have one application or one installation in PUB in Singapore, and this is for a residential area for a project where they want to monitor the rainwater and residential wastewater that is collected and discharged to the local treatment plant. And the reason why you want this, and the reason why you want this kind of monitoring before the water reaches the treatment plant, is that oil spills, whether it's from industry or from residential or from environment, they negatively affect the ability of the treatment plant to process the wastewater. The incoming water, if you're using bioreactors, if you're using membranes, if you're using sand filters, they get completely destroyed if there is an oil spill that is big enough that the water treatment plant cannot handle. And the same idea goes for drinking water plants as well. So you really want to protect these plants from external pollution, or at least react quickly before the oil spill hits your plant. Next slide. And so, I mean, we've developed applications, or our partners around the world have developed unique applications with our instruments. Because our instrument has a small footprint, because it uses very little power, and because it's non-contact, you get some creative installations such as this one in the United Arab Emirates. So this is a offshore buoy installation where you have a desalination and power plant. And if you imagine that this area, this shipping area, is always full of tankers, so large oil tankers. And if there was ever an accident, you have incoming oil spills coming into the plant, they want to detect it right off the bat. They want to be able to have early warning system for this oil spill before it reaches their plant, so that they can react quickly. Next slide. So as you can see, over the years, our applications have evolved. We still focus on the oil sector, the ports, but we now focus as much on the wastewater sector, the power sector, and the manufacturing sector. And what all of these have in common is that they all have water of some sort as a medium, as a way of usage, either through processing or just through collection. And that's where our instrument plays a major role in water monitoring around the world. Next slide. So I just want to recap with our websites, www.ldi.ee. I built the website ourselves, so I developed it in a way that really want to showcase our applications around the world and how we can help you along with our partners to find solutions for water monitoring and through environment or industry. Thank you very much.
Thank you. Thank you very much, Liang, for your presentation. Now, if anyone have any more questions, please type them into the Zoom chat. Please also look into the chat to click onto any links to the virtual booth to visit the Laser Diagnostic Instrument virtual booth at Asia Water, as well as download all the presentation decks for your reference today. Next speaker, please welcome Gino from BIU to give his presentation. Gino, please.
Yes. Hello, good afternoon for the Asian attendees and good morning for the European ones. Everyone,
can you on your webcam as well?
Are you able to hear me?
Yeah, we can hear you. Can you on your webcam as well, as you did this earlier? The webcam button, yeah, we can hear you.
Okay.
Yes, okay, we can see you as well. Great.
Okay. Good. Can I have first slide, please? BIO is a pretty young company, about 5 years old, and it was, next slide, and it was developed after a lot of research have been done in order to develop a 100% biodegradable hydrogen peroxide as an alternative for many disinfectants who are used in the water sector at the moment. We have a worldwide distribution potential, and we have also the manufacturing potential under ISO certifications in many parts of the world. BIO aims at the development of a safe disinfection method in water, in the air, and on surfaces. For example, we are also very well established in the world now fighting COVID, in which we give a lot of free product to non-profit organizations. Next slide. The properties of hydrogen peroxide are commonly known. It is a very powerful oxidizer, and it's much more performant than chlorine and chlorine dioxide and other disinfectants used until today. The problem with hydrogen peroxide today was that it was very hard to stabilize the molecule in order to let it do its activity whenever it was the purpose, if we needed it. So what we have actually done is we developed a way to stabilize the hydrogen peroxide with a stabilizer, which is a non-toxic product, which is a non-metallic product, and it also does not contain any acids. Yes, please. So here you can see that actually, if you want to use ECP, as we call it, the product is called EcoClearProx, and we also, in a shorter way, we call it ECP. If you want to integrate it in your system, which you are using today, it is actually a very easy system. We dose the product on 2 stages in the refinery process in order to maintain a very low concentration, but in order to activate it and to be activated, we have the ability and the process knowledge to be quite a very good disinfectant. Yes, please. So here you can see, for example, an installation. It's actually on the left, you can see a very easy dosing system, which then integrates or injects the product into the system. And we have to look into where we will inject the product, whether it will be in the raw water, and most of the time we also inject it a little bit of product once the water is leaving the facility. And on the right, you can see it's very easy to use the IBC containers in order to supply the product. Yes, please. One advantage of using ECP is that it's very easy to use, as I already referred to. The injection system can be quite easy, but one of the biggest advantages is also that you use a lot of less product of ECP instead of chlorine. So you only use about 8% in volume in order to maintain the same water quality. Furthermore, ECP is odorless, and one very big advantage is that we also fight biofilm in the installation. And biofilm, if you want to prolongate its activity, it will also fight Legionnaire disease in the tubing and other diseases related to biofilm. Furthermore, we don't have any negative byproducts. Many products produce biocidal byproducts, which can be very negative for the quality of the water and also for the health of the users. Furthermore, pH is in the range of drinking water absolutely not an issue. Next, please. So why do you use EcoClearProx? And I deliberately have made a comparison between silver-based hydrogen peroxides, because they also claim to be 100%, no, they also claim to be biodegradable, but they are biodegradable for 99% or maybe a little bit more, but never 100% biodegradable. And why the little amount of silver is very important that we avoid the use of silver is because silver is a toxic and a very dangerous product for aquatic environments. It is also, it sticks, for example, if you use it in aquaponics, it can go and stick to the gills of the fish, and it disturbs very long time the bacterial activity, also, for example, in your sewage water. Therefore, much of the sludge recuperated from the sewage systems cannot be used because of a high contact of heavy metals. Yes, please. Well, as you can see, I made the presentation as brief as possible because I think most of you are professional enough to understand that we are actually a product which can replace chlorine in drinking water and in many other applications. And this slide shows you actually just an idea on where we could interfere in your system, giving you a good quality of water, which is also non-toxic and without any biocidal byproducts. I hope I got it as brief as possible, and if anybody has any questions, please do, and I can try to reply.
Hi, there's a question asking what are your thoughts on detecting soluble VOCs?
Sorry, can you repeat?
What are your thoughts on detecting soluble VOCs?
Well, depending yes, depending on the VOC itself, we also oxidize. We have the experience that sometimes we oxidize, of course, the presence of any pathogens and chemicals in the water too. So we also can have a very positive effect on that. But of course, we have to examine that in for every case by itself.
Okay, thank you, Gino, for your presentation. Now we will move on to our next presenter. Okay, so for everyone, please welcome Wolfgang from Vienna Water Monitoring Solutions to give his presentation. Wolfgang, please. Hi.
Hello, everybody. Thank you for joining. I will start as soon as our slide is on the screen. Thank you very much. So my name is Wolfgang. I'm founder, general manager of Vienna Water Monitoring Solutions, and we provide a fully automated online measurement of microbiological contamination in water. Our mission is to provide this important quality parameter as a process parameter. Next slide, please. If we think about water quality, there are three dimensions to water quality. There's a physical dimension, a chemical dimension, and a microbiological dimension of the water quality. For the physical and the chemical, there are sensors, but the microbiological dimension is still evaluated using a lab process. Next slide, please. If we think about the process, all the processes in water treatment, from sewage to drinking water, everything in respect to the microbiological dimension of water quality, they are two-dimensional processes. Only process control and feedback is about physical and chemical parameters, because the microbiological evaluation takes 1 to 3 days in the lab. Therefore, it's not possible to integrate it into process control. And this is the thing we can change. Next slide, please. Because our technology is able to provide this third dimension of water quality, the microbiological dimension, fully automated, in order to use it in process control, process feedback, and early warning. Next slide, please. Next slide, please. So if we look at a 3D process control, we have process feedback for physical, chemical, and microbiological quality parameters. Therefore, we can control also the microbiological dimension of water quality and establish controlled processes which are much more efficient, much more sustainable, and of course, much safer. Next slide, please. The key features of our technology are that it's a fully automated device, so it's directly installed within the process. It could be a sewage plant or could be a drinking water plant. It's directly installed in the process. It's taking sample, it's performing the measurement, cleaning itself, calibrating itself. So nothing to do except refill reagents. It takes only 15 minutes from taking the sample to the result. Everything is fully automated. And of course, this is followed, the measurement is followed by a 10 minutes cleaning cycle. All the devices provide online visualization, automatic notification. You can insert a SIM card. All the data is provided on a dedicated homepage, and there's no interference required with your local IT network. And we can measure specific, so we can measure the most important fecal indicators like E. coli, enterococci, and a bulk parameter for total microbiological activity, which is mainly used in the food and beverage industries, because you don't want to have anything growing in there. This is something related to something similar with like the heterotrophic plate count. Next slide, please. Our devices are already deployed around the complete water cycle, from the wastewater discharge, surface water, raw water for water production, throughout the drinking water production process, network monitoring, storage monitoring, food and beverage industry, aquaculture, industrial processes like closed processes, cooling, dosage in cooling systems, and so on. Next slide, please. We have, this is two, so something went wrong with the slide. There should be the Water Supply Department in Hong Kong is one of our customers. Please go forward to the next slide. I don't know what's happened there. Yeah, so we have the Water Supply Department in Hong Kong. We have the Drainage Service Department in Hong Kong. Mercrot, which you saw the last slide. Eau de Paris is one of our customer. The DHI, they use it for monitoring membrane integrity in an MBR plant, which is very, more frequent in latest times because of increasing recirculation of water, the circular economy, the reuse of water percentages increased and MBR plants become more. But also in drinking water, like Unity Water in Australia is monitoring drinking water. At the University of Tokyo is monitoring recreational waters, or one customer is Europe's 5th biggest drinking water or mineral water bottler who is monitoring the raw water. So their mineral water wells are monitored using our device. So you see really from sewage to the purest water, everything can be monitored using our technology so that you can integrate the microbiological dimension of water into a process control, into automatic monitoring and safeguarding the quality. This is my last slide. Now then, I give you a short overview how does this look like. This is monitoring a semi-treated drinking water, and these dots reflect one measurement per day if you do a standard test. Next slide, please. This would be 2 tests per day still, and this is how it looks like when you monitor it using a coliminder. You get a real timeline which provides much more information than even if you do 2 tests per day, you receive the results too late, and the resolution is not high enough to really see something. Next slide, please. Our devices provide, beside the activity reading, which is the blue one, transmittance reading, high resolution transmittance reading. So if the transmittance is high, that means that the water is clear. If the transmittance is low, that means the water is turbid. If we see that timeline, then we can see on the left-hand side we have a higher microbiological activity and a lower transmittance. So the water was more turbid and the microbiological activity was higher. And then towards the right side, the activity goes down while the water becomes clearer. This is only a simple example. This was measured in the drinking water line. We can do the same for sewage plant discharge. And you can control your dosage of your disinfection intensity according to the actual contamination level. And therefore, you don't need to overdose. You can reduce byproducts of disinfectants. And of course, you can safeguard if you are discharging in a recreational area, for instance. The same applies in food beverage industries. You can monitor your product. You don't have to wait 3 days for the lab result before you ship it, because you already know if it's okay or not. Thank you very much. That was my presentation. Thank you.
Thank you very much, Wolfgang, for your presentation. Next, please welcome Helly from Valmet to give her presentation. Helly, please.
Okay, so this is Heli Karaila from Valmet. I don't know if you can see my web camera. There's no sound. Can you hear me? Okay. For some reason, I can't hear you right now. But anyway, let's go. I hope you can hear me now. There is now some.
Oh, you can hear. Yeah, we can hear you loud and clear. Yeah.
Okay, so yes, we can. For some reason, I can't share my web camera, but let's continue without my web camera. Sorry about this. So please, if you take the first slide, please. So my name is Heli Karaila, and I'm working in the company Valmet as a business manager. I'm located in Finland, where also Valmet head office is located. And good afternoon to everybody on behalf of me as well. Please, if you take the next slide. At first, briefly about Valmet. So we are a leading global developer and supplier of technologies, automation and services for the pulp and paper and energy, and as well as to the process industries, including water and wastewater as well. We have over 13,000 professionals around the world, and last year our net sales was 3.5 billion. If you take the next slide, please. So Valmet has over 50 years experience from the industrial solid measurements, and this is mainly based on the pulp and paper experience. Okay, so okay. There was some comments about the camera, but okay. Based on the technology development, what we have done mainly in the pulp and paper business, we have now also offering to the wastewater sector as well. And what is important, both to the municipal as well as to the industrial wastewater plants. So in our portfolio to the wastewater sector, we have real-time measurement and optimizer application to the wastewater solid process area. Here in the right side, you can see the typical wastewater process. And when wastewater is treated, there is produced also a huge amount of solid or sludge. And this is shown with a brown color in this picture. Our real-time measurement and solutions are utilized here in the sludge process area. And we are covering all the solid process measurements needs in the wastewater area. If you take the next slide. So in the wastewater portfolio, we have advanced real-time measurements and optimizer solutions, as well as automation system and services included with the industrial internet solutions. So it is important that we have not only transferred the technology from other industries to the wastewater sector, but we have further developed those because the wastewater is very challenged for the real-time measurement applications. And we have developed these applications in cooperation with our end customers. We have already nowadays over 2,000 references available globally. If you take the next slide, please. The wastewater sludge or solid real-time measurement have always been an issue because it is, like I mentioned, it is very difficult to measure solid real-time at the wastewater plants. And typically the customers are following this process phase manually or based on the visual look. And with help of Valmet real-time solid measurement and optimizer solutions, it is really possible to optimize the process. Based on the customer feedback, it is possible to optimize the plant capacity. Chemical usage has reduced 20 or even up to 50%. And there is possible to have also energy savings, as well as savings in the further processing of the dewatering sludge. So there is big possibilities to optimize the sludge process area, and return of invest have been only a couple of months. So if you take the next slide. Here are some customer experience and feedback. So at first there is the case one. This is coming from North America. This is a very big wastewater plant and 1.5 million cubic meters daily. And the customer reported 1.2 million annual savings in energy and chemical after they have installed our solutions at the plant. Case 2 is coming from Europe, from Finland, and customer reported 50% lower solid content in the centered, and this means optimizing of the plant capacity. Case 3 is coming from China, and in that plant they used to follow up the process manual or visual look or based on the laboratory samples. And when they installed Valmet real-time measurement at the plant, they recognized that the correlation and the accuracy of the Valmet measurement is very good, so excellent. And so it is really possible to optimize the plant based on the real-time measurement utilization. And the fourth case is coming from Japan, and in that case the customers are able to reduce the green gas at the sludge incineration plant. So if you take the last slide, the next slide, please. So thank you, and please visit our web pages. So the link is here available, and I'm happy to tell more about this application, and please visit also our booth. Thank you very much.
Thank you very much, Heli, for your presentation. Also apologies for the technical error for the webcam. Now next, let's move on to Barut from Anis Chen to give his presentation. Barut, please.
Yeah, okay.
Hi, yeah.
You hear me and see me as well, probably.
Yes, we can hear you and see you well.
Yeah, thank you very much. The Anis Trend, the baler company, is located in Slovenia and is a channel baler manufacturer. So we produce the machines for solid waste management, for compacting into the stackable bales. So we produce different kind of machine, but mostly for non-metal solid waste. Continue, please, with the next slide. Yeah. So, Anis is internationally known machine building company from Slovenia in European Union, and it has been manufacturing a wide range tailor-made, robust auto-tie channel balers. As I said, for compaction, all kinds of waste and their feed conveyors for over 25 years. So all the machines are tailor-made, so according to the customer needs. And mostly they are installed in sorting plants, waste sorting plants, recovery, recycling facilities, and so on. Next slide, please. So our product portfolio is we have the fully automatic channel balers, so big machines. For non-metal waste, the middle one is a can baler, which is for compacting cans, tin cans. And of course, all those machines, they need automatical transportation of waste, which also we do in-feed conveyor belts for those machines. Next slide, please. So we bale different kind of waste material with these machines. So aluminum cans, cardboard, plastic foil, mixed paper, wood chips, PET, RDF, HDPE, high-grade paper, OCC trims, and so on. So all non-metallic waste material. Next slide, please. Concerning our fully automatic channel balers, we have all technology which exists. So also shear technology and also pre-press technology. And our automatic chain balers, the pressing force is from 40 tons up to 200 tons. So we have the small production volume balers and also high load balers, the big ones. The pre-press technology, we have both which are on the market. So we have a single pre-press flap, so for the pre-compaction, and also double pre-compaction flaps. Next, so we offer all press technology options to cover all types of material waste and to be close as much as possible to customer needs. So next slide, please. Yeah, so to get to know more about these machines, which are installed usually in sorting plants or in cardboard packaging box plants. So please visit our website, and it's very well explained. There are also some videos which you can see how they work. And okay, that's it. So thank you very much for my presentation.
Thank you very much for your presentation. If any of from the audience would like to visit the virtual booth of our EU presenters at the EU Pavilion in Asia Water, please look at it at the chat links to visit their booths, as well as to download all the presentations here today. So now next, please welcome Nick from Geolux to give his presentation.
Hello,
Nick,
thank you very much. Geolux is a company that is located in Croatia and European Union. So we are a company that specializes in development of instruments for environmental monitoring of rivers and lakes and other water channels. So if you can show next slide, please. You can see that our first product is a radar-based surface velocity meter. So this instrument uses radar microwave technology to measure the surface velocity of the river flow. Sorry, this is also called the index velocity. By using this measurement, you can calculate the total flow in a channel. And this technology, because this is contactless, has many benefits over other technologies such as side-looking Doppler and so on. Because the instrument is mounted simply above the water surface, the installation is easy and the maintenance is minimal. Next slide, please. Thank you. The other product also uses radar technology to monitor the water level. So this is a different type of a radar microwave sensor, which is also placed above the water surface, and it measures the distance from the sensor to the water surface. So you can use this instrument to measure the water level in lakes or rivers or any other type of open channel where there is a flow. Again, this technology is contactless, so you can easily and quickly install this instrumentation on existing overhead structures such as a bridge or some extension over the river. This means that it can be installed even under very difficult conditions when there is some high water or floods and you want to monitor this quickly. Also, the maintenance is minimal and the resolution and accuracy are very high. So the instrument is not in contact with the water, so it cannot be affected by sedimentation in the water or debris or something else. Next slide, please. We also have an integrated instrument, which is shown on this slide. It combines both of these radar technologies. So it has the radar level sensor to monitor the water level. It also has the surface velocity radar to monitor the flow velocity. And integrated inside of this unit is a module for calculating the total discharge in cubic meters per second. So there is some calibration that needs to be performed on site. Calibration parameters are entered into this device, and then the device can be left to operate online and calculate the discharge based on these two measured values. Next slide, please. Thank you. We also offer the complete integrated hydrological station, which consists of the instruments and also of the solar panel, the backup battery, integrated data logger with cellular modem to deliver data in real time. We have deployed many of these stations across the world. So on all 5 continents, we have deployed these stations. Our customers like it because this is a turnkey solution. So we just ship the complete station. They need to go to a bridge above the water and install it on the bridge, and it's working. So the installation typically takes between 30 minutes and 1 hour. Next slide, please. And I will just show you some other pictures of the installations, because you can see how our customers have very different situations across the world. So sometimes you have a very nice bridge over a small stream, such as on the picture on the right side. Sometimes you have a river with stronger flow, such as on the left, where you can use an extension arm to mount an instrument above the water surface. Our instruments are used, first of all, for hydrologists to provide continuous monitoring data. The hydrologists use this data to calculate their models, which help them in flood prevention and so on. Our instruments are also used in early flash warning systems, in hydropower plants for planning of the power production, in various industrial applications where you also need to monitor the amount of water that is flowing in or out of the industrial or facility, and so on. Also, if you can move to next slide. Here are also some other applications. So we also have, we can monitor rivers. We can also monitor channels which are artificially made, such as the one at the top. We had one application, or multiple actual applications, related to mines, where there is some water flowing out of the mine. This is not pure water. It can have some copper tailings or some other chemical components inside, but all of these fluids can be measured by our products. Also on the next slide, please. Thank you. So here are also some other installations. Also on the left side, there is a facility. I think this is close to some hydropower plant in Southeast Asia. The picture on the right is in Europe. This is one medium-sized river that we monitor. And also, you can move to next slide, please. I believe we have some more pictures. Okay, that's it. So these were all the pictures. So once again, thank you for your attention. Also, please visit our virtual booth. We will be very happy to answer any of your questions there. I would also just like to add one thing. The first presenter was a LBI company with the optical sensor watcher for detection of oil spills on the water. So we also have a partnership with them. And we also, together with them, offer a solution for monitoring both water level and oil spills on the water. So you can also contact either them or us regarding this solution. Thank you very much.
Thank you, Nick, for your presentation. So next, let's move on to our last presenter for today. Please welcome Carlos from Libium to give his presentation. Carlos, please.
Okay, hello?
Hi, yeah, okay, can hear you and see you.
Perfect. All right, so we can start the presentation. My name is Carlos. I'm the sales area manager for the smart cities, industry, health, and water environmental technologies for Asia, for Libelium. So next slide, please. So who is Libelium? Well, we design and manufacture high quality environmental and water quality solutions. It's a result of 15 years experience on the Internet of Things industry. How they are designed? They are designed as a standalone. So with a solar panel, they are sustainable. They're open source. That's a very important factor of our technology. So they are very versatile. The user can choose among many of more than 140 different sensors that we have integrated in our technology. And the sensors and the devices monitor air, water, soil 24/7, basically. So the user can decide whether to send the data to existing equipment, existing servers, existing monitoring systems, or to brand new software solutions based on the cloud. For example, we will see a few examples later on. And what our technology has been proven already in hundreds of use cases, in fish farms, in rivers, in oceans, in cities, in open fields, in crops, and we have an extensive record of success stories in our website. I will present just a few of them later in the presentation. Next, please. Okay, so this is an infographic of trying to explain the interoperability, which is a concept in the Internet of Things, which is, okay, our technology is in the center and it can connect any sensor. Here is more relevant maybe for this event, like the water and environmental ones, but there are also agricultural ones, noise, cameras, parking, through any communication protocol. We have integrated multiple communication protocols, cellular, Wi-Fi, Bluetooth, LP1, which is specific for IoT. And as it's open source, it can be connected to any cloud platform or local server, depending on the need. Next. This is in an overview of our portfolio of sensors. Okay, the one in the left up is in the agriculture. The second one is the water measuring or water sensors product line. Environmental there in the right. Then you see parking, noise sensors, and so on. So several of them. Next. Well, let's go then to environmental and noise monitoring as part of this event. Yeah, as you all know, pollution is one of the biggest problems that affects the life of the people, especially in cities. Next. So this is an example of our technology. The smart environmental device and the sensors are attached underneath. The one on the right, it's dust particles, so it will measure when the air comes in, it will measure by laser rays the size and the number of dust particles. And at the left, you can see all the parameters that can be measured with different sensors. So the typical ones in air quality is carbon monoxide, ozone, nitric dioxide, sulfur dioxide. So it is very modular. So for some applications, you might want the standard ones for cities. For some industries, some farms, you might want methane or ammonia. So it's very modular. At the end, the user chooses up to 6 or 8 different sensors and connect it to the same device. Next one, please. So to smart water, okay. What can we monitor? We can monitor all sorts of water, potable and chemical leakages in rivers, controlling and reducing leakages also on the sea, the pipes, also on industry, on farms, on fish farms or others, swimming pools, so all sorts of open water, so to say. And next slide, please, if we will. This is how it looks like, the smart water device. So parameters to measure, physical and chemical. We can measure dissolved oxygen, pH, ORP, conductivity, salinity. We can measure the dissolved solids, the temperature, turbidity, so how dirty it is, suspended solids. There are also ion selective probes, so it can measure nitrate, chloride, sodium, calcium, and others. And also biochemical and organic levels, okay? COD, VOC, VGA, so that's pretty much all sorts of parameters that can detect the presence of bacteria, that can affect the life of the fish, that can detect the presence of algae, or all sorts of elements that can pollute also the water. Next, please. So some success stories. Next one. This is an example of environmental and noise monitoring in Athens, in the airport in Greece, okay? And well, the game was detecting or evaluating the environmental impact and the noise levels of the planes in the tracks. So in the next one, please. We will see conceptually how it is. So the devices with the noise and environmental sensors are placed on the airport tracks, and they send the data to, in this case, to a gateway, and the gateway collects all the data and connects it to a cloud-based platform, which is specialized on measuring and analyzing noise and environment. Next one. Another success story in a harbor, okay, in Poland, in Europe. And well, this is one of the largest seaports in the Baltic Sea, and similar use case. They wanted to measure the environmental impact on several points and see the influence. So in the next slide, please. Again, we will see a similar concept. In this case, the connectivity uses 4G, and same. You install the devices in the points that you want or that you want to measure because it's more critical. It's sent to a gateway, the gateway to a cloud, and then you have a software platform analyzing and getting all the information, and also applying, if you want, machine learning tools or artificial intelligence to give more value to this information. Next one. This is in a city in Spain, similar use case. They wanted to measure the pollution, in this case to show that it's clean air. So it can also not necessarily needs to be in the worst cases. So next one, please. Similar concept. In this case, we use LoRaWAN, which is an IoT protocol, longer range, and yeah, basically it measures it collects all the data, and at the end it goes to the city platform where it is analyzed with other information, with traffic information, with weather information. So all the data is crossed, and the city can make better decisions with all this data bundles. Next one. Let's go for a couple of case studies in fish farms. This is in Vietnam, okay? And yeah, basically the aim of this project was to reduce the losses on dead fish by monitoring the specific water parameters in the few ponds where they wanted to measure. Next one. Similar concept. You can measure in different ponds. Also, the devices are rather small, so they are portable, so they can be measuring 1 week in a pond and then next week in another pond. So that's also some flexibility that they give. And similar use case, sending data to a gateway to a cloud platform, and then analyzing all this data. Next one. This is an example in Alaska. Okay, this is different because it will be installed it has been installed in buoys, in water buoys. So same system, sensors inside the water, and a buoys that we will see in the next slides, measuring also the water in the sea, because there was a hazard for the whales habitat. So next one, please. You will see the concept and the buoys. In this case, the connectivity is 900 megahertz, is another radio frequency protocol, but it could be also 4G, 2G, it depends. And at the end, this concept, you leave the sensors floating around, and you receive 24/7 data to control exactly what is happening in this coast. Next one. Similar one, preserving the mussel population in the US. Next one, we will see again scheme and pictures. So same concept. This one was in lakes. It can be on the sea, rivers. It doesn't matter. At the end, it can be fixed. The sensors can be fixed to a position. It can be put in voice. All kind of flexibility. Next one. And that's all. So this is our website. Just visit us. You have our contact details for the organization. So thanks a lot for being here.
Thank you, Carlos, for your presentation. Thank you to the audience for your time and listening to our Acipita Spotlight presentations. You can also click on all our EU presenters' booth links provided into the chat below to check out their Acipita's booth at Asia Water. You can also refer to the links provided to download any reference documents to all our presentations today. We will now conclude today's session. Hope everyone will have a great day ahead. Thank you.
Stop.